In this video, we'll be talking about and discussing polynomials with common factors. So to begin with, factoring is what we call the process of writing a polynomial as a product. If a polynomial does not factor using integer coefficients, then we will call this polynomial either prime or irreducible over the integers. For example, a classic example is something like x cubed minus 2x. Here, as we'll see, we can pull out a common factor when we can pull out a common factor x out of this. We'll talk a bit about that in a moment. Times x squared minus 2. Both of these polynomials are now irreducible. So it's especially this one, because if we were to try to factor this, we wouldn't know how to factor it. Furthermore, we call a polynomial completely factored when each of its factors are prime. That is, here what we actually have is a completely factored polynomial. So we've completely factored x cubed minus 2x. So to actually start working towards factoring, the first thing to notice that the easiest way to factor is to pull out common factors. The way this is done is, and the easiest way to do this is by considering all the different factors of each of your terms. Here, the factors of 6x cubed are 2, 3, x, and x. There's 3 of them. And then we have a 2, and an x. Here we notice that there is a 2 and an x in here, and a 2 and an x in here. There's no other 2 here, so that's not a common factor, and we have 2 x's and a 3 left over here that aren't in here. So what that means is that we can pull out the 2 and the x, and then we have to write whatever is left here. So 3x squared and a 2. Similarly, we can do the same thing here. By going through here, we can see that our common factors are, there's a 2 in each of these, and actually there's a 4 in each of these, because each of these numbers is divisible by 4. And it's proper etiquette to pull out the negative as well when it's on the leading term, so we'll go ahead and pull that out. What that does is that divides each of these by 4, and by, well, actually by negative 4, so it changes all the signs. So we'd have x squared left there. 12 divided by 4 is 3, changes the sign. And 16 divided by 4 is 4, but we change the sign. So that would be our answer. Finally here, this one's a little bit tricky in that we notice that an x minus 2 and an x minus 2 is in both these terms. So what we can do here is pull out the x minus 2 out of both of them. This is an important lesson in your instructions because you may want to simplify this, but our instructions in the problem were to factor each expression. So we're really wanting to factor this. That's why we pull out the x minus 2. It's time for you to try out, so go ahead and factor the following 3 expressions. And on the count of 3, I'll reveal the answer. 1, 2, 3. So again, here, all these are pretty straightforward except for this one. From here to here, again, it's usually considered proper form to write it in standard form, so descending order of the exponents. For more practice and common factors, go ahead and look at the textbook, page A33, and try out numbers 5 and 37 through 40. And in our next video, we'll be talking about factoring our special polynomial forms.